This is part 2 of the Chapter 5 lecture notes. You may be interested to know how long it takes for, once a cell is produced during the stratum basale, how long it takes for it to be shed. So I guess the life cycle of a skin cell. So it takes about a week for the cell to move all the way from the deepest layer, the stratum basale, to the stratum corneum. But then after that, dead cells can stay in the stratum corneum for 2 weeks. So it can be anywhere from 2 to 3 weeks is normal. Okay, checkpoint questions. Number 2, the 5 layers of the epidermis. Let's do this from the superficial or top layer to the deepest layer. And remember the sentence, come let's get sunburned. So it's going to be the stratum corneum, the stratum lucidum, the stratum granulosum, the stratum spinosum, and the stratum basale. All right, question number 3. Dandruff is caused by excessive shedding of cells from the outer layer of skin in the scalp. Thus, dandruff is composed of cells from which epidermal layer? So that's going to be the stratum corneum. And then question 4, some criminals sand their fingertips to avoid leaving recognizable fingerprints. Would this practice permanently remove fingerprints? Why or why not? Well, it kind of depends on their pain tolerance, really, but probably not, because they would have to sand all the way down to the stratum basale. They would have to remove the stratum basale before that would ever permanently, remove their fingerprints. And then that would be an open wound, which is bad, Okay, so, all right, so skin color, pigmentation is the pigments that are responsible for skin color are keratin and melanin. So first is keratin, which is an orange-yellow pigment, and that pigment can be converted into vitamin A. So that is a pigment that's also found in orange-colored foods, and so we can get vitamin A from, that's why they say, because vitamin A is good for your eyes and good for the retinol, in your eyes, and so that's why they say carrots are good for your eyesight. But the primary pigment that determines skin color is melanin. And there are 2 shades of melanin. There's a red-yellow shade and there's a brown-black shade. And it really, your skin color really and skin tone just depends on, the amounts and ratios of each type. But melanin is produced by melanocytes. These are cells that are found, melanocytes are cells which are found in the stratum basale. That's what I was looking for, stratum basale. Melanocytes are cells that store melanin, the pigment melanin, in vesicles, and those vesicles have a name. They're called melanosomes. Now, the activity of melanocytes increases in response to exposure to ultraviolet light. So, and the purpose for that is because the melanin protects us from UV light. Okay, so here, this is a melanocyte. You can see that it's got all the brown melanin pigments within it, and the melanocyte has all these extensions, and then the extensions pinch off, kind of like, remember when we learned about the Golgi apparatus or the Golgi complex, the ends of it will pinch off and form a vesicle. So the melanocytes will pinch off and form a vesicle called a melanosome, and the melanosome will carry the melanin to cells in the epidermis, more superficial cells. All right, as far as how our circulation affects our skin color, oxygenated blood is bright red. If you've ever heard that oxygen-rich blood is red and oxygen-poor blood is blue, that is wrong. So don't, get away from that because there's no blue blood. But oxygenated blood is bright red, and whenever it's oxygen poor blood, then it's a darker red. It's a different shade of red. But anyway, because oxygenated blood is bright red, that the more circulation that you have, the more active your circulation is near the surface of your skin, the more of a reddish tone you're going to have to your skin. But there are a few conditions that will cause your skin to either turn red or pale. So when your body temperature rises, it dilates your blood vessels close to your skin, and they dilate so that they can deliver blood to the surface of the skin, and along with that, the heat will radiate from the surface of your skin. You will lose body heat that way, and your body temperature will drop. But it causes you to have a flushed red skin color. And then activities that would cause, like if you're cold, that will cause constriction of those blood vessels will result in pale skin. Now, you may have heard of the condition called cyanosis. It's when the skin turns a bluish coloration. Particularly, you can see this in the extremities, like the fingertips and the tips of the toes and the lips. This will happen when blood oxygen supplies are diminished, and that doesn't mean the blood is blue. The bluish coloration results from how the blood vessels appear under the skin, but this can happen, when a person is having an asthma attack, when they're climbing a mountain and they're in high altitude, so the oxygen is there's not as much oxygen available to breathe there, or when someone is dying. You can have that. All right, 2 pigments in the epidermis. We learned about keratin and we learned about melanin. Number 6, why does exposure to sunlight or sun lamps darken the skin? Because ultraviolet light triggers the production of more melanin. And number 7, why does the skin of a light-skinned person appear red during exercise in hot weather? That is because the increased body temperature dilates the blood vessels near the surface of the skin. All right, now, beneficial effects of sunlight. A certain amount of sunlight, we need it. It helps us to be healthy. When our skin is exposed to sunlight, it triggers our skin to produce vitamin D3. It triggers our epidermal cells to produce vitamin D3. What they do is they convert, let's see. Okay. So the skin produces vitamin D3 in response to being exposed to ultraviolet light or sunlight. Now, the liver and the kidneys take that vitamin D3 and convert it into calcitriol. And that is a hormone that is needed for the absorption of calcium into our blood. So it raises our blood levels of calcium. Inadequate vitamin D3 can lead to weak and flexible bones. In small children, it causes a condition called rickets. I'll write that for you. Because low vitamin C, remember, causes scurvy. Low vitamin D can cause a condition called rickets. Thought I was going to make it. It's R-I-C-K-E-T-S, rickets. Now, detrimental effects. So we know we need some sunlight. Our skin needs some exposure to sunlight so that we can produce healthy amounts of vitamin D3. But too much sunlight, it can also be detrimental. It can cause us to form skin cancers. If the cancer is a cancer of epithelial tissue, so the epidermis, it's called a carcinoma. So you can have basal cell carcinoma, which originates in the stratum basale, and this is the most common type. You can have those removed, and they're generally not terribly dangerous. And you can also have squamous cell carcinoma, which is found, closer to the stratum corneum. But the really dangerous, scary type of skin cancer is malignant melanoma. and that usually begins from a mole, and this type can metastasize through the lymphatic system. This is an image of a basal cell carcinoma, and this is an image of a melanoma. All right, it says, explain the relationship between sunlight exposure and vitamin D3 synthesis. So ultraviolet light triggers the cells of our epidermis to produce vitamin D3. That's the relationship. The relationship is how do you say that if you're taking a math class and you're graphing? It would be a direct relationship. Direct relationship when sunlight increases, vitamin D3 synthesis increases. Okay, the dermis, which is the layer below the epidermis or deep to the epidermis. And the dermis contains the papillary layer and the reticular layer. Here's that same illustration again. Here's your papillary layer and your reticular layer of the dermis. Remember, the papillary layer is composed of areolar connective tissue, and the reticular is composed of dense, irregular connective tissue. All right, so the notes on the papillary layer of the dermis, make sure you know that it's composed of areolar tissue, which is a loose connective tissue. It does contain blood capillaries, lymphatic vessels, and neurons, sensory neurons. The reticular layer is composed of dense, irregular connective tissue. It contains elastic fibers for flexibility. We call that elastin, and collagen for strength. And both of these fibers kind of break down as we get older, so we don't have elasticity or strength in our skin anymore like we did when we were younger. And then in the reticular layer of the dermis, you also find accessory organs that were derived from the epidermis, which would be hair follicles and sweat glands. These extend into the reticular layer of the dermis. Also, I mentioned to you the blood supply in the dermis, that the more superficial layer of blood vessels or area of blood vessels is called the subpapillary plexus, because this is blood vessels that are kind of between the papillary and reticular layers of the dermis. And then the deeper layer of blood vessels is called the cutaneous plexus. So there's definitely a good blood supply in the dermis. And then below the dermis, even though this is not technically part of the integumentary system, the layer below the dermis is called the hypodermis or subcutaneous layer. The tissue that forms the hypodermis is areolar tissue and also some adipose tissue, which consists of fat cells or adipocytes. And then make sure you know this. This is just something that I know is part of a quiz question. It says, lack of vital organs in the area make it an ideal site for subcutaneous injections with hypodermic needles. Because you'll miss a vital organ, by injecting into that hypodermis. Now we're going to move on and talk about the hair. Hairs are defined as non-living keratinized structures. They are produced by hair follicles. They project above the skin surface everywhere except the bottoms of the feet, the palms of the hands, sides of the fingers and toes, lips, and then portions of the genital organs. And then I want you to see an image of the hair matrix and the hair papilla. Here we go. Okay, so this is showing you the hair matrix. Here is this part, the hair papilla. If you do a cross section through the hair follicle, you can see the connective tissue sheath on the outside, and then you can see this would be called the hair cuticle, the cuticle of the hair. the cortex of the hair and the medulla of the hair. The hair root is this part in the center of the hair shaft.